Hi there, welcome back to the TUT class. It's this class we're looking at this question 4 of the Olympiad past question, part B. Now this question 4 says, prove by induction that summation from 1 to n of r raised to power 3 plus 3r raised to power 5 all equals to 1 over 2 n cubed into what? N plus 1 all cubed. Now how do I solve this? If you've been following me through my classes, on induction, you notice that how I express this is to say that what my n is such that what r starts from 1, where we have 1, 2, 3, all up to what n. That is, my n can represent what? Any number. Now in this case, how will I represent? Summation means the sum of all the identity elements, of this polynomial. So as I can say, let p of r be equals to what? R is plus 3 plus 3r is power 5. Now, when r equals to 1, what is my polynomial going to be like? When r equals to 1, it implies that what? This now becomes what? 1 cubed plus 3 into 1 is power 5. And that is 1 plus 3, which is 4. Now, if this is 4, when r is equals to 2, all that as an answer, it means when r equals to 2, I'm going to have what? I'm going to have 2 raised to power 3 plus 3 into 2 raised to power 5. This now becomes what? 2 raised to power 3 here is 8 plus 2 raised to power 5 is what? 32. Now 32 times this is what? That's what's that again? 96, right? Okay. So that's 96. 96 plus 8 is what? That's 104. Now and so on until you get to n, which you don't know the number. Now from here, what does now become? It means that my p of r now becomes what? The first polynomial, which is this, when I put 1, is what? 4, plus the next one is what? 104, plus if I add out of 3, I'm going to get the answer plus what? Plus n. Now, if my p of r equals to this, it means all this equals to what? It all equals this. 1 over 2 n raised to power 3 into n plus 1 all raised to power what? All raised to power 3. Now, and I said for us to solve questions under induction, the idea is this. You have to look for what? P of 1, P of k, and P of what? K plus 1. Where P of 1 is always true when you test for it, P of k is always assumed to be true, and P of k plus 1 is always what? Always true. Now, how do you test for it? Put P of r, which is this, as what? P of what? 1. This is my first condition. Now, how does it become? It means whenever I see r, I put 1. This is r here. This is r. This is now in terms of r relatively. So I'm going to be using this as my r. So I'm going to have what? 1 over what? 2 into 1 over what? Cube plus what? Times, 1 plus what? 1 all raised to power 3. Now what does it become? What do we have here? That becomes 1 raised to power 3 is 1, times 1 is 1 over what? 2. 1 plus 1 here is what? Is 2. 2 raised to power 3 is what? 8. Now 8 divided by 2 is what? 4. Note, I also said if you are testing for P of 1 in mathematical induction, whatever you get here, when you test n or r as 1, must be the equivalent, to your first term in the series. So that is, after testing for P of 1 in this function, it must arrive me at what? It must arrive me at the first term value. If I test for it here also, I must get 4. That is, when P is equals to 1, R equals to 1, I'm going to have what? 1 raised to power 3 plus what? 3 times what? 1 raised to power what? 5, which is 1 plus what? 3 raised to power what? 3 times 1, which is equals to 4. Now, since P of r equals to P of 1 gives me 4, automatically my conclusion is that what? P of 1 is what? Is true. Okay, now from here, what will I do? Let's test for what? P of k, second condition. Put P of k to be what? P of what? R or P of n, whichever. That is, whenever I see r, I put k. So let's put it inside this general form. I'm going to have P of k then to be equals to what? 4 plus 104 plus and so on plus what? K equals to 1 over 2 k cubed into what? K plus what? 1 all raised by what? 3. Now, from here, after representing your R as K, automatically just conclude that what? P of K is assumed to be what? To be true. Now, finally, my P of what? K plus 1. Okay, now, what to test for what? P of K plus 1. So, put P of K to be equal to what? P of what? K plus 1. Now, remember in my MI class, for P of K plus 1, you have to write it to the series before adding K plus 1. That is, if I have an example as this on board, 2 to 5 now. That's say like 2, 3, 4, 5, or 1 to 5. Now in this case, the difference here is 1. If the difference is 1, before I get to 5, I will arrive at 4, right? Now the next one becomes what? 4 plus 1. Since the difference is 1, to get 5 means what? 4 plus 1. Now assuming 4 was K, what will I do? How will I represent K plus 1? It means I'm going to have what? K first before writing what? K plus 1. Do you understand? So that is what I'm going to do just now. So you don't look at magic. Now from this point, P of K, let's represent what? P of K plus 1, which now becomes, let's make up there, it becomes 4 plus 104 plus and so on plus K plus what? K plus 1. All equals to, in this case now, I have a value with respect to K. This is not a series, so I can just represent straight up. That is, whatever I see K, I put K plus 1 already. So that's 1 over 2 into what? K plus 1 all raised by 3, then into K plus 1 plus 1, that's K plus 2. So that's K plus 2 all raised by what? 3. Now, at this point, what I will do here is what? I would say solve from my left hand side, get my right hand side. That is, all what is here, I will solve it to get what? All what is there. Yeah. So, but before then, this represents something. From 4 down to K represents something. It represents my what? P of K, as I presented also in my last class. Now, all this 4 to this place represents my P of K. And remember, my P of K is equal to what? This. That is, P of K plus 1 becomes 1 over 2 into what? K cubed into what? K plus 1 or Q. That's P of K. What is left? K plus 1 is left. That's plus K plus 1. I can put this in brackets. Now everything must be equal to what? This when I solve. Now that is solving from what? Left hand side, to get right hand side. How do I solve? Very simple. Now look at this. I have all this plus K plus 1. Something is common. K plus 1 is common. Right? So you bring K plus 1 out. What remains? 1 over 2 K cubed into what? K plus 1 what? Squared. Right? Because this is with power 1, this is with power 3. Now then plus what? 1. From here, let's now find the LCM and then factorize and finish the whole thing. So from here, what do I have? It becomes what? K plus 1 into, if I bring 1 over 2 out, what will happen? It now becomes what? K cubed into what? K plus 1 whole squared plus 2. Because if I said I have 1 over 3 plus 1, it's the same thing as what? 4 over 3. How do I get 4 over 3? Very simple. LCM over 1. This is 3, 1, 1. 3, 1. 1 plus 3 is what? 4. So if I pull out 1 over 3, it remains what? 1 plus what? Plus 3. Because as though this is multiplying this. So from here, let's now expand and get our final answer.